You're standing on the western shore of Lake Tahoe at sunrise. The water is impossibly blue, the pine forest stretches endlessly, and everything feels perfect. You can't see it, but beneath the surface, something is waking up. The water level here just hit 6,229 feet above sea level, the highest it's been in decades. That's 6,229 feet of crushing weight pressing down on ancient faults that haven't ruptured in over 4,000 years. And those faults are listening. They're feeling that pressure. They're getting ready. What most people don't understand is that rising water on a fault is like pumping air into a balloon. Eventually, something has to give. And when it does at Lake Tahoe, the wave it sends could drown entire communities before emergency sirens finish their first wail. This is the story nobody's talking about. The story of how paradise became a geological powder keg, and how climate change is turning up the heat 1 degree at a time. My name is James, and on Megaquakes, we investigate the disasters hiding in plain sight. And Lake Tahoe has been hiding one for 3.5 million years. Lake Tahoe is not what it seems. On the surface, it's America's clearest, deepest alpine lake, a $5 billion tourist economy drawing 2 million visitors every year. Tahoe City, Incline Village, South Lake Tahoe. These names evoke vacation snapshots and ski resort runs, Emerald Bay, Sand Harbor, Kings Beach. The imagery is locked into America's consciousness. Pristine water, granite cliffs, impossible blue skies, world-class resorts. But underneath this postcard image lies a catastrophe, waiting for the water to reach just the right height. The lake sits in what geologists call a graben. Imagine taking 2 enormous slabs of earth and pulling them in opposite directions. The ground between them collapses downward, creating a deep valley. That's what happened here 3.5 million years ago. The Sierra Nevada was forced upward on one side by tectonic forces, the same forces that built the mountains you see around you. The Carson Range pushed up on the other side, and the earth sank in the middle, creating the perfect bowl. That bowl has been slowly filling ever since. Water flows in from the mountains. Glaciers carved the terrain during the ice ages, and a lake was born. But that lake is sitting on a powder keg. Inside this bowl runs the West Tahoe Fault. It's buried under 400 to 500 meters of lake water. That's deeper than the Washington Monument is tall. Deeper than most commercial airplane altitudes. Running for over 50 kilometers along the western shore, this fault is classified as one of the most dangerous geological features in California. Not the most dangerous, but high on the list. Paleoseismic research, that's the study of ancient earthquakes frozen in rock, reveals that this fault last ruptured between 4,100 and 4,500 years ago. Before that, it broke 7,200 years ago, and before that, 9,000 years ago. The pattern is clear. This fault ruptures. Every 2,000 to 3,000 years, like clockwork, the Earth shakes here. And we're overdue. We're not past due yet, but we're living in the window when it could happen again. Any day, any season, any year. But here's what they didn't tell you. The 1,872 Owens Valley earthquake, a magnitude 7.8 monster on California's eastern side, proved that the Sierra Nevada region is wired for massive ruptures. That quake shook clocks in San Diego. It woke people up in Red Bluff to the north. It was felt across most of California and Nevada. The earth moved so violently that it triggered a rockfall in Yosemite Valley, so intense it's still studied by geologists today. If an earthquake like that happened at Lake Tahoe, it wouldn't just shake the ground. It would unleash hell from below, and the water would carry that hell to shore. What happens when a magnitude 7+ earthquake ruptures beneath a lake? You don't get a regular earthquake. You get a tsunami. A lake tsunami is nothing like an ocean tsunami. There's no deep water to dissipate the energy. You're channeling all that seismic force into a confined space. and the waves bounce back and forth for hours. Scientists call this a seiche. Imagine filling a bathtub and yanking the floor up suddenly. The water doesn't just splash out, it sloshes back and forth violently. The bathroom gets wet. Chaos ensues. Now scale that up to a lake containing 122 million acre-feet of water. That's enough water to cover the entire state of California to a depth of 16 feet. That's how much liquid is sitting above that fault. When the floor moves, that water doesn't stay calm. This isn't speculation. This is documented geology. This is recorded in the rocks themselves. Around 15,000 years ago, though some paleoseismic evidence pushes it closer to 21,000 years, geologists discovered evidence of a cataclysm. A chunk of Lake Tahoe's western wall collapsed into the water in a single catastrophic failure. Geologists call it the McKinney Bay megaslide. We're talking about 12.5 cubic kilometers of rock and earth. Let me make that real for you. That's the equivalent of 5,000 World Trade Centers falling into the lake at once. That's enough material to fill a cube 1 mile on every side. That's the mass of Mount Everest sliding into a lake at speeds exceeding 100 miles per hour. The rock didn't settle gently. It plunged through the water column and displaced everything in its path. The slide generated tsunami waves reaching up to 330 feet high. That's as tall as the Statue of Liberty. That's taller than a 33-story skyscraper. Imagine a wall of water the height of a 33-story building moving towards you at the speed of a freight train. Those waves didn't just wet the shoreline, they flooded it. They destroyed it. Some of that water burst over the outlet at Tahoe City and rushed down the Truckee River with such violence that house-sized boulders still litter the riverbed today, 200 miles downstream at Verde, Nevada. You can drive past those boulders today. You can touch them. They're monuments to a catastrophe that happened before humans walked upright in this region. Scientists studying the geological evidence near McKinney Bay found something terrifying. The ground on either side of the bay is made of the exact same unstable material. The same steep slopes, the same geological weakness, the same potential for collapse. This means another megaslide isn't an if, it's a when. And if it happens during a modern high water event, during a warm season when the shoreline is packed with tourists, the body count could exceed what we've seen in any natural disaster in American history. Now, let's talk about water pressure, because this is where the real nightmare begins. When water fills a lake or reservoir, the weight of that water presses down on the rock below. A column of water 100 meters deep doesn't feel light. It exerts tremendous pressure. Think of it this way. At the bottom of Lake Tahoe, which is 1,645 feet deep at its deepest point, the pressure from the water column is equivalent to the weight of 50 elephants standing on a postage stamp. That's not metaphorical, that's physics. This phenomenon is called hydrostatic loading. Imagine balancing on a tightrope. The tighter you're pulling the rope, the closer you are to snapping it. Now imagine that rope is a geological fault already under tremendous stress from tectonic forces. Add 50 feet of extra water weight, and you're tightening that rope another centimeter. Add 100 feet, and you're at the breaking point. The 2023 snowpack was historic. We're talking about one of the wettest winters on record for the Sierra Nevada in over a century. Atmospheric rivers pounded the mountains. The snowpack accumulated to record heights. Then spring arrived. Rapid warming triggered a snowmelt event that swelled every creek and river feeding into Lake Tahoe. The water level climbed. It climbed through 6,000 feet, 6,100 feet, 6,200 feet. The snowmelt drove Lake Tahoe's water level to 6,227.8 feet in October 2023, just shy of the maximum legal limit of 6,229.1 feet. The lake hadn't been this full in a generation. In some areas, it hadn't been this full in 50 years. The flooding damage along the west shore in 2023 was visible and documented. Homes were damaged. Beaches vanished under the rising water. Marinas flooded. Private docks disappeared. The water reached where it had never reached before in modern times. But that was just the beginning. Climate change doesn't stop. The models predict more extreme snowpack years in the future. Hotter droughts alternating with wetter winters. More filling. More pressure. More stress on those faults. More opportunities for the geological trigger to align with the hydrological condition. Here's the scenario that keeps geologists up at night. A magnitude 7.1 earthquake ruptures along the West Tahoe Fault during or shortly after a high water event. Summer season, July. The lake is full from spring snowmelt. Beaches are packed. The initial earthquake shakes the western cliffs. The ground lurches. Car alarms start blaring around the lake basin. The hydrostatic pressure from elevated water levels weakens the overlying rock. Rock that has been stable for 4,000 years suddenly becomes unstable. The stress in the fault has been building for millennia. The weight of the extra water, that 6,229-foot surface, adds just enough pressure to break the deadlock. A section of the western shore collapses into the lake. Maybe it's a small slide at first. Maybe it's 10 million tons of rock. The displacement of that rock sends a wave spreading outward at tsunami speed. Imagine a chunk of cliff, face the size of a football stadium, falling into the water. The water has nowhere to go but outward in all directions. The water in Emerald Bay, which is directly above the fault, surges upward. A wall of water forms. The wave reaches Tahoe City on the north shore in minutes. Minutes, not hours. Minutes. Boats and docks are obliterated. Beachgoers don't have time to run. The water surges up the Truckee River outlet at the lake's northern edge. At the same time, secondary waves bounce back. The water doesn't settle. It sloshes back across the lake toward Incline Village on the east shore, then back again toward the western shore. Homes built on the waterfront are submerged. Windows shatter. Walls collapse. The Seiche wave, that back and forth sloshing, continues for hours, getting weaker with each cycle, but still deadly. Each oscillation of water moves thousands of tons of mass. Every movement is destructive. Incline Village alone has a year-round population of about 8,000 people. During ski season, that number triples to 25,000. South Lake Tahoe has 15,000 year-round residents, but that swells to 40,000 during peak season. Tahoe City, another 8,000 residents, becomes another 15,000 with seasonal workers and visitors. Add the seasonal population of 20,000 to 40,000 tourists in any given week during high season, and you're looking at potential casualties in the thousands if a tsunami hits during peak hours. During summer weekends, there could be 100,000 people within the tsunami zone. The primary schools, the hospitals, the resort hotels, many are within 100 meters of the shoreline. A 30-foot wave moving at tsunami speed doesn't care about building codes. It doesn't stop for warning sirens. It just keeps moving until all the energy is dissipated. And those sirens wouldn't even go off because Lake Tahoe isn't part of any tsunami warning system. But wait, there's something else. Something the research teams discovered that most news outlets have completely missed. The USGS seismic hazard maps show that the West Tahoe Fault isn't the only threat lurking beneath that perfect blue water. There's the State Line Fault running south from Crystal Bay toward Nevada. There's the Incline Village Fault paralleling the shoreline on the east side of the lake. All three faults formed the basin together millions of years ago when the Earth was pulling itself apart. The paleoseismic record, the earthquake history written in rock layers, shows evidence of coordinated ruptures. Multiple faults breaking in sequence during a single catastrophic event. If that happens today, if the West Tahoe Fault ruptures and triggers slip on the State Line Fault simultaneously, the wave heights could double. You're not talking about a 30-foot wave anymore. You're not talking about 50-foot waves. You're talking about waves exceeding 60 to 80 foot high. You're talking about genuine mega tsunami conditions in a lake that most people think is as safe as a swimming pool. You're talking about a scenario where the wave reaches third-story windows, where it enters the upper levels of hotels, where it doesn't retreat for hours, where the sloshing continues all night long. The tourism economy around Lake Tahoe generates $5.2 billion annually for the region. Think about that number, $5.2 billion. That's not just vacation money flowing into casinos and restaurants. That's housing investment, construction jobs, school funding, road maintenance, emergency services. Small businesses depend on the steady flow of visitors from April through November and from December through March ski season. Marinas, ski resorts, restaurants, hotels, rental agencies, all of it depends on that $5.2 billion annual pump of money into the local economy. What happens to that economy when a tsunami devastates the western shore? When Tahoe City is partially destroyed and becomes a disaster zone? When people are killed on camera at crowded beaches and the images go global? When families lose homes they've owned for generations? When ski resorts face months or years of recovery? The recovery cost would be in the tens of billions. The economic disruption would echo for decades. But more importantly, the loss of life would be irreversible. These aren't abstract numbers. These are parents and children. These are retirees enjoying their golden years. This is real human tragedy, playing out in one of America's most beautiful places. This is a scenario that is not just possible, it's preventable if we act now. And here's where the climate change piece becomes impossible to ignore. The Sierra Nevada snowpack is becoming more extreme with every passing year. Warmer winters mean less snow accumulation at low elevations, but the mountains are still cold enough to generate massive snowpacks. When cold snaps do arrive, and they're arriving more suddenly now, they're cold enough to dump historic amounts of snow at the lake's elevation. A single atmospheric river hitting the Sierra can drop 6 to 8 feet of snow at Tahoe's elevation. The 2023 water year saw rainfall and snowmelt that pushed Lake Tahoe toward its fill limit. The lake's level climbed to within 2 feet of the maximum legal limit. The 2024 and 2025 seasons will likely follow similar patterns. The models coming out of UC Davis and Berkeley don't paint a cheerful picture. They suggest that by mid-century, we'll see more frequent wet year conditions, not steady increases, not gradual change. Swings, big swings between extremely wet years and extremely dry years. More frequent high water events compressed into shorter time frames. More pressure on those faults. More water weight bearing down on faults that are already stressed. More opportunities for the geological trigger to align with the hydrological condition. The scary part isn't that it might happen. The scary part is that it's increasingly probable that it will happen. And most people living in the Tahoe Basin have no idea. They think natural disasters happen to other places. They think Tahoe is special. Tahoe is not special. Tahoe is just lucky, and luck runs out. Now let's be clear about what scientists can and can't predict. Nobody can tell you that an earthquake will happen on Tuesday at 3 p.m. Seismology isn't that precise. Faults are complicated. Rock responds to stress in ways that sometimes surprise us. But the long-term probability is quantifiable. It's measurable. It's based on data that's been gathering for decades. Research conducted by the USGS, the UC Santa Barbara, and the University of Nevada, Reno estimates a 3 to 4% chance of a magnitude 7 earthquake striking beneath Lake Tahoe in the next 50 years. That might sound low until you contextualize it. Compare it to other natural disasters people take seriously. The probability of a significant tornado hitting any specific location in the Midwest is roughly 1 to 2% per year. When a 1 to 2% event occurs, it becomes national news. Tornado warnings go out. People seek shelter. Roads get clogged with evacuees. A 3 to 4% probability over 50 years is actually quite high in geological terms. It's saying that there's a reasonable chance, not remote, that the people living at Lake Tahoe right now will witness this catastrophe in their lifetime. That's not doomsday talk. That's risk analysis. That's the same kind of analysis we use for hurricanes, for wildfires, for any hazard that communities take seriously. The research teams at UC Santa Barbara, the University of Nevada, Reno, and the USGS are actively studying this threat. Not because they're being alarmist, because they're being responsible. They've placed seismic sensors around the lake perimeter, monitoring for any unusual activity. They've deployed underwater cameras and sonar to map the fault geometry in detail. The sonar can detect the tiniest features on the lake floor, fissures, cracks, areas of structural weakness that might give way. They're monitoring water level fluctuations in real time. They're running computer models to simulate tsunami wave propagation under different earthquake scenarios. The models are sophisticated. They account for the lake's variable depth, for the surrounding topography, for how waves would bounce off the mountains. They're calculating tsunami wave speeds and heights under scenarios of magnitude 6.5, 7.0, 7.1, and 7.3 earthquakes. They're updating these models with new data every year. This isn't theoretical work. This isn't guesswork or speculation. This is science-based catastrophe planning conducted by experts with PhDs in geology and seismology. And the conclusions are unanimous. The threat is real, it's significant, and it's been growing with every high water year. The scientists don't disagree on whether it could happen. They disagree on when and how bad. The communities around Lake Tahoe are not prepared for a tsunami. The evacuation plans exist mostly on paper. There are no tsunami sirens ringing around the lakeshore. There are no standardized tsunami warning protocols in place. No drills, no public education campaigns. Most residents don't know what a seiche is, let alone how to protect themselves from one. You could walk through downtown Tahoe City on any day and ask 20 people if they know what a seiche is, and you'd get 20 blank stares. That's the knowledge gap we're dealing with. The Western Regional Tsunami Warning Center, part of NOAA, monitors Pacific Ocean earthquakes and issues warnings for coastal areas. It is a sophisticated system. It works well for ocean tsunamis, but Lake Tahoe sits 400 miles inland. It is a closed basin. It is not connected to the ocean. It is not part of any tsunami warning network. If an earthquake ruptures beneath the lake, the first warning people will get is the sound of the water itself, the rumble of trillions of tons of water beginning to move. That low-frequency sound carries far. People on the eastern shore might hear it, but by the time they process what that sound means, the wave is already coming. By then, you are already too late to run. The fastest human runners can hit maybe 20 miles per hour in short bursts. A tsunami moves at 40, 50, 60 miles per hour, depending on the water depth. The math does not work in humans' favor. Here's what makes Lake Tahoe different from every other seismic hazard site in America. Different from San Francisco, which at least has warning systems and educated residents who understand earthquake risk. It is not just the fault. The 1906 San Francisco earthquake proved California has plenty of dangerous faults. It is not just the population density. There are more people in Los Angeles at higher risk. It is the combination. It is the perfect storm of geology, hydrology, and human settlement. It is a fault that ruptures once every 2,000 to 3,000 years, with the last rupture 2,000 years more recent than that timeline suggests. It is a water level that's reaching historic highs more frequently due to climate change. It is a lake basin that concentrates seismic energy like a giant bowl, amplifying the destructive potential of any earthquake. And it is a population that has grown from a few thousand miners and loggers 100 years ago to over 200,000 people living in the basin today. The population is still growing. New homes are being built on the waterfront every year. Investors are buying up property at lake level, betting on Tahoe's future. They don't know. Most of them don't know. Every filling of that lake increases the probability of the trigger conditions aligning. Every warm winter that triggers rapid snowmelt puts more pressure on the faults. Every year we wait is 1 year closer to the day when those conditions align, and the West Tahoe Fault wakes up after 4,000 years of silence. We don't get to choose when. We don't get to negotiate with geology. The fault will move when the stress reaches critical levels. The water will be high when atmospheric rivers dump rain and snow on the mountains. And we don't control when those two things synchronize. Here's what's sitting beneath that beautiful blue surface. Approximately 122 million acre-feet of water. That's enough water to cover the entire state of California to a depth of 16 feet. That's 17 trillion gallons of water. All of it is sitting on top of 3 fault lines that haven't moved in thousands of years. All of it is moving slowly. The lake level rises and falls seasonally. The weight presses and releases on those faults. The stress accumulates. The rock becomes more unstable. The pressure builds. And one day, one summer afternoon, when the lake is at maximum elevation and the weather is perfect and thousands of tourists are in the water, the pressure reaches a critical threshold. The rock slips. The water moves. The question isn't whether this will happen. The question is when. And the answer, based on everything the research tells us, based on the paleoseismic record, based on the computer models and the historical patterns and the current climate trends, is that it could happen during our lifetime. Not definitely, not inevitably, but possibly. Possibly in the next 50 years, possibly in the next decade, possibly next summer, and possibly at Lake Tahoe means thousands of deaths, means infrastructure collapse, means a $5 billion economy crippled for a generation, means families torn apart by a wave that nobody saw coming because nobody warned them. The water is still rising. The fault is still waiting. And paradise, as it always is just a moment away from becoming hell. And if this story is your reminder that natural disasters don't wait for permission, download our free 72 Hours Disaster Guide. The link is in the description. It's designed to help you prepare for anything: earthquakes, floods, tsunamis, wildfires. Because when nature moves, preparation is the only shield you have.